This lesson is about some applications of first-order differential equations to population growth and substance decay, and also Newton's law of cooling. So if we start with growth and decay problems, by definition, the time rate of change of a given quantity A is proportional to A. That is, mathematically, stated as dA over dt is directly proportional to A. So this is the symbol for direct proportion and or for proportionality in general. So when you talk about time rate of change, the derivative is always with respect to time t. So to make this an equation or an inequality, we multiply to A what you call a proportionality constant, so that's K. So you have your equation dA dt is equal to Ka. For population growth, we use our variable P to denote population, and that's rate of change of population with respect to time, denoted by dP over dt is equal to Kp. So where your dP dt is the rate of change of population, K is proportionality constant, and P is the population at any time t. Whereas if we are talking about substance decay, you have dm dt, so the rate of change of the substance, amount of substance, with respect to time, that's dm dt over dt is equal to negative km, where k is also the proportionality constant and m is the amount of substance remaining after any time t. So for substance decay problems, m is the amount of substance remaining after a given time t. It's not the amount that is present. So that's very crucial, no, in solving for problems regarding substance decay. So again, m is the amount of substance remaining after any time t. And then the negative here in the formula, okay, just denotes that your problem involves a decay problem or something that is decreasing in general. Okay, kapag sinilagyan mo ng negative yan, limbawa, if we're talking about population and you have positive Kp, that means that we are talking about something that is growing. Okay, so another application kasi dito will be sa investment, for example, or compounding interest, for instance. So you have a positive, no, equation, and then if something is decreasing in value, okay, decreasing volume, or in this case decreasing amount, okay, decay problem, no? So you put a negative in your formula just to differentiate something that is regarding growth and regarding decay. Okay, yun lang yung sense nung negative na yan. So dm over dt equals negative km. Now let us try to derive the formulas, okay, or the general solution for the given differential equations, because these two are basically differential equations, but they are very simple differential equations. So solving for the solution, it's not that complicated. So you have dP over dt equals Kp, or the derivative of P with respect to T is equal to Kp. That's our differential equation for population growth. So this is just a separable differential equation. We can rewrite this as dP over P is equal to K dt. So integrating both sides with respect to P and with respect to T, we will get ln, absolute value of P, or simply ln of P, is equal to Kt plus the proportionality plus an arbitrary constant, rather, C. Now you want to solve here for an explicit form of the solution. So remember, for this differential equation, what we want is an expression for the population at any time t. Therefore, we want our general solution to be expressed explicitly as p in terms of time t. So what we do is we take the ln of both sides, or raise both sides as powers of e, because you have an ln already. So what we do to remove the ln, we raise both sides as powers of e. So we have e raised to ln of p I'll just remove the absolute value already, no? Is equal to e raised to kt plus c. Now, e raised to ln p is just p. That's equal to, we can rewrite the right-hand side as e raised to kt times e raised to c. But e raised to c is just a constant. So, e is a constant, c is a constant. So, if we let e raised to c be equal to another constant, let's say capital C, then p is equal to capital C e raised to kt. Or you can rewrite as p of t in functional form, p of t is equal to c e raised to kt. So this one is read as, it's not read as p times t, so this is just read as p as a function of t. So this is what we are looking for. This is the general solution that we are looking for. So if we solve for the same, kasi yung ating expression naman for decay problem will be dm over dt is equal to negative km. So it's very much the same. So it will follow the same general solution, magkakaroon lang ng negative. So this one, when we do the same, this one will give us the solution m of t is equal to c e to the negative k t. So this one tells you that you have an expression for m as a function of time. So this tells you the amount of substance m remaining after a certain time t. Now, yung c natin na to, which is the arbitrary constant that we obtain, no, that came from the integration of our separable differential equation, we can actually assume always, no, because remember, this one should be an initial, or this one should be the problem should contain either initial conditions or most of the time, no, what we will have here are boundary conditions. Ibig sabihin, you have two given conditions and then different values of time, and then two amounts or two populations, no? So, and one of the conditions that is given in most cases ay yung ating initial population or initial amount. So if we do that, if we let the initial amount or initial population, if we are talking about population growth, if we let p of 0 be equal to p naught, p sub 0, then p of t is equal to c e to the kt. So p of 0 is equal to c e to the k times 0, or that's p sub 0, the value of p of 0, is equal to c e, k times 0 is 0. But e to the 0 is just 1, so it follows that p sub 0 is equal to c, or c is equal to p sub 0, or the initial population. So in general, kung ang pinag-uusapan natin ay population growth, whatever is the initial amount, that is actually, or whatever is the initial population, that is actually the value of your arbitrary constant c, right, in your general solution. Hence, we can redefine our solution to be P of t equals P naught E raised to kt. So instead of using the CE to the KT, we can use P sub 0 P naught E raised to KT. Applying that to our equation on the general solution for a decay problem, it will also be the case that when you have, so for m of t equals CE to the negative KT, if we let m of 0 be equal to m naught, so ibig sabihin the initial amount of substance, so it's not yet decayed, so it's still 100%. So if it's m naught, then m of 0 is equal to CE to the negative k times 0. So it's substitute natin for time is 0. So you have m naught is equal to CE raised to 0. And e raised to 0 is 1. So you have here m naught equal to c. Or again, it follows that c is equal to m naught. Hence, m of t is equal to m naught e raised to negative kt. So you see here, okay, instead of having m of t equals c to the negative kt, we can replace immediately yung c using the initial amount. Now let us have some examples. Number 1, a culture initially has p sub 0 or p naught number of bacteria. At time equal to 1 hour, the number of bacteria is measured to be 3/2 of the original, p naught. If the rate of growth is proportional to the number of bacteria present at any time t. So this statement here tells us that our problem will follow an exponential growth problem, and so the solution is the general solution that we derived earlier. We want to determine the time necessary for the number of bacteria to triple. So let's first write down the given details. So given in the problem are, okay, we have at time 0, of course, you have P of 0 being equal to P sub 0. So yung mga problems natin, it can be that the initial population is given to be an exact numerical value or specific value, let's say 2,500. Pero there will be cases naman na kagaya nito, it's not given specifically, okay, but it can be represented as your P sub 0. Okay. And then at time equal to 1, so that's after 1 hour, the population, so that will be represented by P of 1. Remember, P of t is the population at any given time t. So P of 1 is equal to 3/2 of the initial of P naught. And then what we want is actually the time. So at what time will be our population, or will our population be, will triple, no? So that will be 3 times your P naught. So yung ating reference dito is the initial. Okay? So whatever is the initial amount or initial population rather, whatever is the initial population, it does not actually matter yung exact value. Okay? Kasi ang tinitingnan natin dito is kung how many times yung pag-increase niya, okay, sa kada time. So kahit na hindi natin alam the actual value of the P naught. So here, using our given population or given values, and then the general solution, which is P of t equals, again, initially it's c e to the kt, but since alam natin that c is just p naught, so that's p naught e to the kt. So we impose our given condition. So ang given natin na condition is Yung kasing initial condition, ano na yun, nagamit, yung initial na P of 0, nagamit na natin yun para kay C. Yun na yung, di ba, yun na yung magsasabi sa atin that C is equal to P naught. So, yung next natin, yung kailangan natin isolve is yung K, the proportionality constant. And we will be using the other given population, no, other value at another time, which is T equals 1. So, at T equals 1, P of 1 is P of 1 is equal to 3 halves of P naught. So if we impose this, we will have P of 1 equal to P sub 0 or P naught e raised to k times 1. But P of 1 is 3 halves of P naught is equal to P naught e to the k. So magka-cancel ngayon yung P sub 0 on both sides. So we will be left with 3 halves is equal to e raised to k. And then we can now solve for k. We take the ln of both sides. ln of 3 halves is equal to ln of e raised to k. And so we have here ln of 3 halves equals k. And that is around k equals 0.40546. Thus, P of t is equal to P naught e raised to negative point, or e naught e raised to 0.40546 times t. So this is the population at any time t as a function of t and whatever is the initial population P naught. So since ang gusto natin is yung time kailan siya magti-triple, so you want to find t when P of t is equal to 3 times P naught. So what we do is we substitute this. Okay, so you have from P of t equals P naught e raised to 0.40546 t. We want our P of t to be 3 times P naught is equal to P naught e, and then we solve for the time. 40546 t, cancel the P sub 0. So you have here 3 equals e raised to 0.40546 t. And then solving for t, we take the ln of both sides. ln of 3 is equal to ln of e raised to 0.40546 t. So ln 3 is equal to, so bababa lang si 0.40546 t. Solving for t, we get t equals ln 3 all over 0.40546, which is approximately equal to 2.71 hours. So, the number of bacteria in the culture will triple, okay, will triple relative to the original amount within 2.71 hours. Now, let's say we have a follow-up question. Say, we want to determine the population of bacteria after 5 hours. So, dagdag na ano lang, no? Question lang. Say, we want to find the population of bacteria after 5 hours. So, what do? Since we already know the expression for the population at any time t. No, yung P of t equals P naught E to the point 40546t. This is already the population at any time t. So, kung given ka ng kahit anong time, then using this, you can already determine the population by just plugging in that given time. So, here we have P of 5 is equal to P naught E to the point 40546 times 5. Or that's P of 5 equals 7.59356 P naught, or simply approximately 7.6 P naught. And what does this tell us? After 5 hours, the population of the culture is 7.6 times whatever is the original. You see here, our answer or our value of the population is not an exact value. It's not a specific value because, again, dun sa problem natin, the initial amount of bacteria present in the culture is not actually specified. But what is given is the initial in terms of P sub 0. Kaya what we have here, ang makukuha natin if we want to predict the population at any time t, are also in terms of the P naught. So how many times relative to the initial population P sub 0. Example number 2. A bacteria culture is known to grow proportional to the amount present. After 1 hour, 1,000 strands of bacteria are present. And after 2 hours, there are 3,000 strands. Find an expression for the number of bacteria at any time t and the approximate number of bacteria originally in the culture. So what do we know from our given problem? At time equal to 1, so after 1 hour, P of 1 is 1,000. And then at t equal to 2, so after 2 hours, so P of 2 is 3,000. So you want to find an expression for the number of bacteria at any time t. So that's P of t. Number of bacteria at any time t. And then you want to find the approximate number of bacteria originally in the culture. So we want to find also P of 0, which we can denote as P naught. Okay, so that's at t equal to 0. Alright, so starting with our general equation, P of t is equal to P naught E raised to kt. We can now impose the given condition. So at time equal to 1, P of 1 is equal to 1,000. So it means that P of 1 equals P naught E to the k times 1,000. Or that will be, oh no, this is time equal to 1. Should be 1 lang. Times 1. So this should be 1,000 is equal to P naught E raised to k. So in this equation, both P sub 0 and k are missing. So we cannot do anything about this. Let's just denote this first as equation 1. And then we impose the other condition at t equal to 2. P of 2 is equal to 3,000. So substitute again, P of 2 equals P naught E to the k times 2, or that's 3,000 equals P naught E to the 2k. So again, two equations na naman yan. but the same unknown as equation 1. So let's call this equation 2. So since you have two unknowns and then you also have two equations with the same unknowns, then we can pair up these two to solve for our missing variable. So from equation 1, we can rewrite this as 1000 equals P naught e to the k. So that's P naught equals 1000 over e raised to k. And then from equation 2, which is 3000 equals P naught e raised to 2k, we can rewrite and solve for P naught as P naught equals 3000 over e raised to 2k. So, if these two equations talk about the same piece of zero, well, it's the same piece of zero because isang problem lang naman ang pinag-usapan natin dito. So, we only have a single initial value for your population. Then, the two right-hand sides are also the same. So, we can equate 1000 over e raised to k to 3000 over e raised to 2k. And we can solve now for k on this equation. So, pwede nating pagpalitin na lang to. So, you will have here e raised to 2k over e raised to k is equal to 3000 over 1000. But e raised to 2k over e raised to k is just e raised to k equals 3. So, solving for k, take the ln of both sides. Ln of e raised to k is equal to ln of 3. So, k is equal to ln 3. Thus, P of t is equal to P naught e raised to ln 3 times t. Now, using equation 1 or equation 2, kahit alin sa dalawa na na-derive natin kanina, we solve for P naught. So, let's say, using equation 1, which is P naught equals 1000 over e raised to k, we can have this 1000 over e raised to ln of 3, or that's 1000 over 3. So, P naught is equal to 333.33, or this is approximately equal to 333. So, with this, okay, so this is the initial value of the population of bacteria in the culture, and then our general equation for the population at any time t can be expressed more specifically as P of t equals 333 e raised to ln 3 times t. Population at any time t. This one is initial population. Let's say we have a follow-up question. Let's say we want to determine what is the population at time equal to 10 hours. So, after 10 hours, then what you do is we just plug in to our P of t. So, P of 10 is equal to 333 e raised to ln of 3 multiplied by 10. And this one will give us around 19,663, or 19 million rather, 663,317 bacteria. Now let us consider problems on substance decay. A breeder reactor converts uranium-238 to its isotope plutonium-239. After 15 years, it is determined that 0.043% of the initial amount M0 has disintegrated. Find the half-life of the isotope. Please note that half-life is the amount of substance needed, or the amount of time needed to convert or diminish half of the present amount of the substance. So if we start with the original amount, let's say the original amount is 50 milligrams, for instance, then if after 10 years the 50 milligrams becomes 25 milligrams, then it means that 10 years is its half-life. So for the remaining 25 grams, okay, another 10 years will make the 25 grams become 12.5. And then another 10 years, yung 12.5, makakalahati ulit, and so on and so forth. Okay? So if it's decaying at the rate following our exponential decay model, okay, ganon ang ating definition ng half-life. Number of years, or number, it's the time, no, not necessarily years, but the time needed para yung iyong amount ay mag 50% or mga lahati. So we denote the half-life as T sub 1/2. Okay, so that's just a notation, no, for your half-life. So for this given problem, ano yung given sa atin? We know that at time equal to 0, m of 0 is equal to m naught. And then at time equal to 15 years, m of 15 is equal to what? So dito percentage yung binigay, no? Pero kapag nilagay natin yan as condition, we use decimals, no? And mind you that what is given after 15 years, no, ang given sa atin, 0.043% of the initial amount has disintegrated. Okay? So 0.043% ang nawala. Remember that your M is the number, or is the amount that is remaining. Okay? So dapat ang magiging amount mo dito, yung M of 15, is how many percent of the initial amount remains after 15 years, and that's 100% minus the 0.043%. Okay, that is why for M of 15, this one should be 0.99957 M naught. So this corresponds to 99.957% of the initial amount. Because after 15 years, 0.043% yung nawala. So ang natitira pa is 99.957% of the initial amount. Hindi yan half-life kasi hindi naman nangalahati eh. Okay? Pero after 15 years, ito pa yung natitira, 99.957% of M naught. That is why M of 15 is 0.99957 M naught. Okay. So you want to find the half-life, T sub 1/2. And what is the condition for the half-life? We know that the condition for the half-life is that M of T sub 1/2 is 0.5 of M naught, or that means 50% of M naught. When 0.5 of M naught remains, it means that we are already in the half-life. Okay, so For this problem, since decay, substance decay yung problem natin, we will be using m of t is equal to m naught e to the negative kt. So, imposing the given conditions, yung unang condition na t equals 0, m of 0 equals m naught, ito na yung result nun. Okay? M naught yung capital C natin. So, doon na tayo doon sa pangalawang given, which is at time equal to 15. So, at t equal to 15 years, m of 15 is 0.99957 m naught. Or that will be m of 15 equals E, or m. Right, so since this is a substance decay problem, we will use the general solution m of t equals m naught e to the negative kt. So the first condition, which is m of 0 equals m naught, ito na yun, no? Kaya siya naging m naught yung c natin. So we will just go with m of, or at t equal to 15 years, so m of 15 is equal to 0.99957 m naught. Substitute, you'll have 0.99957 m naught is equal to m naught e to the negative k times 15. So we can cancel the m naught here on both sides. So we now have 0.99957 is equal to e raised to negative 15k. So we solve for k by taking ln of both sides. ln of 0.99957 is equal to ln of e raised to negative 15k. And so we have here e raised to negative 15k, or mawawala na yung e, no? Magiging negative 15k equals ln of 0.99957. Palit lang natin ng order dun sa ating equality symbol. Palit lang natin ng side. So we'll have k equals ln of 0.99957 all over negative 15. And that's around 2.86728 times 10 to the negative 5. Thus, your solution, m of t, becomes m naught, whatever is the initial amount, e raised to negative 2.86728 times 10 to the negative 5 t. So, at t1 half, okay, which translates to m of t1 half equals 0.5 m naught, using this general solution, we have m of t sub 1 half equals m naught e to the negative 2.86728 times 10 to the negative 5 times t1 half, or that will be 0.5 of m naught, so that's m of the half-life, is equal to m naught e to the negative 2.86728 10 to the negative 5 times the half-life, t sub 1 half. Yung 1 half dyan is just notation, ha? So, cancel the m naught, and then we can solve for t. Okay, when you take the ln of both sides, ln of 0.5 equals ln of e raised to negative 2.86728 0.2728 10 to the negative 5 times t1 half. We will be having here ln of 0.5 is equal to negative 2.86728 times 10 to the negative 5 times t1 half. So, the half-life T1 half is simply ln of 0.5 divided by negative 2.86728 times 10 to the negative 5, which is around 24,174 years. So is this a possible na number of years for the half-life? Is that 24,174 reasonable half-life for our problem? Yes, it is, because you see, sa given natin, after 15 years, ang nag-disintegrate lang is 0.04%. Okay, so ibig sabihin talagang matagal siyang mag-decompose. Okay, that is why to reach 50% of the original amount, you really need tens of thousands of years. Okay, gaya nito, 24,174 years to reach half-life. Now, let's have problem number 4. A certain radioactive material is known to decay at a rate proportional to the amount present. If initially there is 50 milligrams of the material present, and after 2 hours it was observed that the material has lost 10% of its original mass, find the mass of the material present after 4 hours. So let's list down the given first. So we are given at time equal to 0, your initial amount m of 0 is equal to 50 milligrams. And then at time equal to 2 hours, m of 2 is 45 milligrams. And then we want to find at time equal to 4, what is the amount remaining? So m of 4. So using m equals m naught e raised to negative kt, we impose the first condition. So ang ating m naught bali is yung ating 50, no? So we can actually write this already as m of t, we can write m of t equals 50 e to the negative kt. Pwede nating idiretso yan. Kasi this one is always whatever is your amount at time equal to 0. And that is 50. So imposing yung ating time equal to 2, which is m of 2 is 45 milligrams. So m of 2 equals 50 e to the negative k times 2. So that's 45 equals 50e to the negative 2k. Dividing both sides by 50, we get 45 over 50 equals e to the negative 2k. So 45 over 50 is just simply 9 over 10. So we can take the ln of both sides. So I put here 9 over 10. So instead of 45 over 50, no, is equal to ln of e to the negative 2k. So this one we can rewrite as k equals, you will have ln 9 over 10 equals negative 2k, no? So we have here k equals ln of 9 over 10 divided by negative 2. So that's approximately 0.05268. Thus, m of t is equal to 50 e to the negative 0.05268 t. So that's the amount remaining at any time t. So we want amount of substance present at any time t. So what is m of 4? So that's m of 4 equals 50 e to the negative 0.05628 times 4. So just simply substitute. Thus, m of 4 is equal to 40.5 milligrams. So let's say we are asked to find the half-life. So additional question lang ulit. What is the half-life of the substance? So what you do is you just solve for bali ang magiging value natin kung half-life ng mass is t of 1/2 or m of t of 1/2 is just 25 milligrams because ang initial mo 50 eh. So after ng half-life, magiging 25 milligrams na lang siya. So you will just solve dito sa equation natin, no? 25 equals 50 e to the negative 0.05268 times t sub 1/2, the half-life. So from this equation, we just solve for t. So divide both sides by 50. You will have here 25 over 50, or just 1/2, no? E to the negative 0.05268 t sub 1/2. So from here, you'll be able to get your t sub 1/2 as approximately equal to 13.21 hours. So you can do this as your exercise to show from this equation, no? From this equation, i-derive nyo yung 13.21 hours. Now, another application of your first order ordinary differential equations is what you call Newton's law of cooling. By definition, the rate of change of the temperature, capital T, of a body is directly proportional to the difference between the temperature of the body at any time t and the temperature m of the surrounding medium. So mathematically, we can represent that as dt over dt proportional to difference of t minus m, or in equation form, you have should be equals dt dt equals k, proportionality constant k, times the quantity t minus m. So let's derive the solution to this simple differential equation. So this is just separable, okay, just like our first set of equations earlier. We can rewrite this as dt over t minus m is equal to k dt. Integrate both sides with respect to temperature and with respect to time. You'll have here ln of t minus m is equal to kt plus c. We raise both sides as powers of e. You'll just have e raised to ln of t minus m is equal to e raised to kt plus c. E raised to ln of t minus m is just t minus m. E raised to kt plus c can be written as e raised to kt times e raised to c. But e raised to c, we can let this as a single constant, capital C, such that we will have here t minus m is equal to c e raised to kt. Or this is simply T equals CE raised to kt plus M. So, as a function, we can express this also as in the functional form T of T is equal to CE raised to kt plus M. But again, the left-hand side is not read as T times T. This one is read as T, temperature, as a function of time. So when T equals 0, that's T of 0 equals T naught. So let's say T of 0 equals T naught. Then your T of 0 based on our complete solution, yung CE to the kt plus M, T of 0 equals CE to the k times 0 plus M. So that's T naught is equal to C e raised to 0 plus M. But e raised to 0 is 1, so this follows that T sub 0 equals C plus M, or C is simply T sub 0 minus M. So what does this tell us? Your arbitrary constant is simply the difference between the initial temperature of the body. Remember, our problem is you have a body that is initially either way, no, pwede siyang malamig, iinit, or mainit, lalamig, no? But tawag natin siyang Newton's law of cooling, but in other texts, in other references, meron din tayong tinatawag na Newton's law of heating, no? Cooling and heating actually siya. So it can be that the body is cooling down, or it can also be that the body is heating up. But nonetheless, regardless kung heating up or cooling down siya, okay, yung initial temperature mo, T naught, minus the temperature of the surrounding medium, that gives you the arbitrary constant C. Okay, so we can now say that our solution becomes, no, yung magiging general solution natin ngayon becomes, okay, hence we can write T of T as CE to the kt plus M, where your C is just T naught minus M. So, mas-solve natin agad yung ating arbitrary constant C by just getting the difference. No, yung M naman is always constant yan. Okay, we assume that the environment, the temperature of the surrounding is not affected by whatever heat yung nilalabas ng ating material or nating object. Let's have an example. A 5-pound roast, initially at 50 degrees Fahrenheit, is put into a 375 degree Fahrenheit oven at 5 p.m. It is found that the temperature T of the roast is 125 degrees Fahrenheit after 75 minutes. When will the roast be at 150 degrees Fahrenheit? Okay, sa example natin na to, actually, the body is heating up instead of cooling down. But again, as I've said, it doesn't matter. It will be the same relationship. Okay, same formula ang gagamitin natin. Okay, whether heating up or cooling down yung body natin. So, ang given sa atin dito ay initial temperature of the body, that's 50 Fahrenheit. The temperature of the medium, yung furnace, 375, or yung oven rather, 375 degrees Fahrenheit. And then, we know also that at time equal to 75 minutes, temperature at 75 is 125 Fahrenheit. And we want to find the time when the temperature T of T is 150 degrees Fahrenheit. Okay, so mula dito sa given, makuha agad natin is yung C. Okay, so pag sinet up natin yung ating general solution, that's T of T is equal to C e to the kt plus m. But since your C is just T naught minus m, then your C is simply 50 minus 375. So that's just negative 325. Thus, your T of T is negative 325 e raised to kt plus m, which is 375. So, dyan tayo magsisimula. Okay, sa equation na yan. To solve for our missing time. So, we impose our condition that, so, i-write lang natin ulit, no? T of T is equal to negative 325 e to the kt plus 375. So, at t equal to 75, t of 75 is equal to 125. So, if we impose this, we will have t of 75 equals negative 325 e to the k times 75 plus 375. So, in place of t of 75, we put 125 equals negative 325 e raised to 75k plus 375. So, ang goal natin dito is to solve for k. Kasi yan lang naman actually nawawala para makakuha tayo ng complete na particular solution no? Si k na lang kailangan nating i-solve. So, we can solve now for this k kasi yun na lang nawawala sa equation na to. We subtract both sides, 375, or simply parang transpose, no? 375 to the left-hand side. So, that's that will give you negative 250. So, you have here, or pwede rin naman na ito yung itong negative 325. Sige, itong negative 325, i-transpose mo sa kabila, magiging positive, no? E to the 75k, and then yung 125 sa kabila, sa right side, yung magiging 250 pag minus mo from 375. Dividing both sides by 325, you get e to the 75k equals 250 over 325, so that's 10 over 13. Okay? So, ln e to the 75k is equal to ln of, instead of 250 over 25, over 325, so gawin ko na lang siyang 10 over 13. Kasi divisible naman parehas sa 25. So, this one becomes 75k equals ln of 10 over 13, or k is equal to ln 10 over 13 divided by 75. So, this is around negative 3.49819 times 10 to the negative 3. Thus, our particular solution will be temperature at any given time t is equal to negative 325 e to the negative 3.49819 times 10, di kasha. Baba natin. T of t is equal to negative 325 e to the negative 3.49819 times 10 to the negative 3 t plus 375. So, that's the temperature at any time t. Temperature of the roast at any time t. We want to know the time kung kailan ang temperature magiging 150. So, i-impose lang natin tong condition na to dito sa ating particular solution. So, we will have here 50 equals negative 325 e to the negative 3.49819 times 10 to the negative 3 t, yung t yung nawawala natin dyan, plus 375. Okay? So, transpose ulit natin dun sa left side yung may negative. So, magiging positive siya, 325 e to the negative 3.49819 10 to the negative 3 t is equal to 375, tapos i-minus mo yung 50, that will be 225. Then divide both sides by 325, then you take the ln of both sides, so ln e to the negative 3.49819 10 to the negative 3t is equal to 225 over 325. Ang 225 over 325 is around 9 over 13. Divisible ulit ng 25 yan. So, we will be left with negative 3.49819 times 10 to the negative 3t equals, naka-ln na pala to dapat. Dahil in-ln na natin siya both sides. So, ln na rin to dapat. Si 225 over 325. So, ln of, pwede kong ilagay yan as 3 over 13. So, t is just ln 9 over 13 divided by the negative 3.49 times 10 to the negative 3. So, you'll be having here t approximately equal to 105 minutes. Thus, temperature is 150 degrees Fahrenheit at what time? After 105 minutes, or that's at 6:45 p.m. Why is it 6:45? Because sinabi dun sa problem that the roast is 50 degrees Fahrenheit at 5 p.m. Okay, so yung reference natin dyan is 5 p.m. So 105 minutes after 5 p.m. that's 6:45 p.m. Next example, a body at an unknown temperature is placed in a room which is held at constant temperature of 30 Fahrenheit. If after 10 minutes the temperature of the body is 0 Fahrenheit, find the unknown initial temperature if after 20 minutes the temperature of the body is 15 degrees Fahrenheit. So, anong given natin dito? We are given the temperature of the body initially, that's 50. No. We are asked to find the temperature initial of the body. So, hindi yan yung given. Ang given sa atin ay temperature of the room. So, M equals 30 degrees Fahrenheit. And then, the conditions at t equal to 10 minutes, t of 10 is 0 Fahrenheit. At t equal to 20, t of 20 is 15 Fahrenheit. So, ang gusto nating malaman, at time 0, ano ang temperature? That is the initial temperature, basically. Okay? Your t sub 0, which is unknown. So, dun sa ating general solution, which is t of t equals ce to the kt plus m, we cannot solve for c yet because t sub 0 is not known. Okay, T naught is not known, the initial temperature. But we have a clue on what to solve to get the T naught. No, because C is related to T naught, then to solve for T naught, we have to solve first for the value of C, the arbitrary constant. Okay, so dito sa equation na to, si M lang muna yung may ilalagay natin. So T of T is equal to CE to the KT plus 30. And then we impose the given conditions. At T equal to 1, or 10 rather, 10 minutes, no? Temperature at 10 is 0 Fahrenheit. So that's T of 10 equals CE to the K times 10 plus 30. Or that's 0 equals CE to the 10K plus 30. So let's call this equation 1. Kasi dalawa yung nawawala dyan, C at saka K. So we cannot solve anything pa. We impose the next condition at T equal to 20 minutes. So T of 20 is 15 Fahrenheit. So that's T of 15 equals CE to the K times 15 plus 30. T of 20, no, not T of 15. T of 20. T of 20 equals CE to the K times 20 plus 30. So T of 20 is 15 Fahrenheit is equal to CE to the 20K plus 30. So we call this equation 2. Now, from equation 1, we can say that, so 0 equals CE to the 10K plus 30. So we can say here that your C is equal to negative 30 over e to the 10K. Okay, pag nire-write mo to as negative 30 is equal to CE to the 10K, and then you solve for C. Then from equation 2 naman, which is 15 equals CE to the 20K plus 30. Pag tinranspose mo si 30 sa kabilang side, magiging 15 minus 30. So, negative 15 equals CE to the 20K. So, we can write C as negative 15 over E raised to 20K. And these two are both expressions for the same arbitrary constant, capital C. So you can equate the two right-hand sides such that your negative 30 over e to the 10K is equal to negative 15 over e to the 20K. So pwede nating pagpalitin itong dalawang to. So magkakaroon tayo ng e to the 20K over e to the 10K is equal to negative 15 over negative 30. E to the 20K over e to the 10K is just e to the 10K. Minus lang exponents. Is equal to negative 15 over negative 30 is positive 1/2. And then we can solve for K. So we can take the ln of both sides. ln of e raised to 10k is just 10k equals ln 1 half. So k is just ln 1 half divided by 10, or this is approximately negative 0.06931. Thus, using our equation 1 or equation 2 na derive natin kanina, we can solve for c as, let's say, ginamit ko yung sa equation 1, negative 30 over e to the 10k. So that's negative 30 divided by e raised to 10 times negative 0.60931, which is equal to negative 60. And since c is equal to t naught minus m, then t naught equals c plus m. So t naught is equal to negative 60, nakuha natin dito na value for c, plus the temperature, constant temperature of the surrounding medium, which is 30. Hence, your T naught, the initial temperature, is equal to negative 30 degrees Fahrenheit. So let's say you have another follow-up question. Let's say tatanungin tayo, what is the temperature of the body after 35 minutes? Then we just use our particular solution. T of t is equal to negative 60 e to the negative 0.06931 t plus 30. Now, this one will already give us the temperature at any time t. Kasi alam naman natin si c, negative 60 na yon. So, pwede natin siya i-plug in dun sa ating equation, general equation, para makakuha tayo ng particular solution natin. And so, t of 35 is just negative 60 e to the negative 0.06931 times 35 plus 30. So, t of 35 is equal to 24.695 or approximately 25 degrees Fahrenheit.